Hello, this is a quick video to give you some details on the Sydor Wraith scientific CMOS camera. This is a direct detection imaging device for EUV and soft X-ray photon energies. So this is how the detector looks, and at the chip level this is a 4 megapixel imaging device. It has 11 micron sized pixels, but we also have options for a 6.5 micron pixel version. It's a direct detector, so the photons are converted to charge directly in the silicon layer on the chip. We're not using scintillators or anything like that, which is key for energies in the EUV and the water window. Another thing that's great about this chip is that there are no coatings on the front face of the chip, which basically translates into much better quantum efficiency at these energies down in the EUV and the water window up to about 500 eV. It's a CMOS architecture, it's actually a scientific CMOS architecture, which again basically translates into high frame rates of up to nearly 50 Hertz at full resolution, but while maintaining very low noise levels in the 1 to 4 electron read noise regime. The device you can see on the screen there is a flange mounted detector. We can also offer designs with the head fully in vacuum. And the principles that we've used in the design here are to ensure good usability and serviceability, while still offering full UHV capability. So what does that actually mean? Well, you can see here on the image that the chip is mounted on a custom flexible PCB, and it's secured by our X-frame clamping mechanism. What this means is that only the chip and the flex PCB is in vacuum, and then all the rest of the electronics are on the other side of the flange outside of vacuum. And that means that we can reach these UHV levels of 10 to the minus 9. In terms of serviceability, I mentioned the X-frame clamp system that holds the chip in place. This frame can also be used to attach attenuators or beam stops. But in terms of serviceability, if the worst was to happen and you were to damage the chip somehow, maybe by exposing it to too many photons, it's very easy for the user, not sending it back to us, but the user to swap out a spare chip. So you basically remove the X-frame, undo the electronics headers, and then swap in a new chip, and then you're good to go again. As with the majority of our imaging detectors, the system will come with its own Sydor GUI, but also it is integrated under systems such as EPICs for users in synchrotrons and larger facilities. So the other thing about this chip is that it is quite flexible. It has a lot of different settings within there in terms of the gain settings that you use, the imaging modes that you use, and then the regions of interest that you can select to play with things like active areas versus frame rates that you can achieve. So in applications such as tychography, we really want to get as many images, overlapping images as we can very quickly. So you'd probably use something like this imaging mode. You can see there that we have a high dynamic range setting, which is the 16-bit mode. And there we can run the device at full frame resolution at around 24 Hertz. If you are not so concerned about the dynamic range, you can go in 12-bit mode and double the frame rate up to about 48 Hertz. And then by reducing the ROI that you're interested in a square fashion, you can also bump up the image rates that you can get there. The other really interesting mode that this chip can be running is a spectroscopy mode. So you can reduce the ROI in a rectangular fashion, and then you can really start to bump up the speeds into the hundreds of Hertz and almost to kilohertz. We can also offer customizations. So on the left-hand side, you see the standard device with a single chip. We can do tiling with this chip. There will be some gap between the active area of the chip, but we can minimize that. We can tile these in a linear direction, or we can make them into a grid. And then we can also actually tilt the chip relative to the onset photons if you're doing something like spectroscopy and want to try and increase your resolution. So that was a quick intro to the Sydor Wraith scientific CMOS detector. We are ready to start shipping these devices, and so if you would like some more information, you can contact us at info@sidortechnologies.com, or you can go directly to the webpage for the Sydor Wraith detector, which you can see there up on screen.